Okay, we are back to soils. Okay, let's talk about accelerated erosion. This is going to happen anytime you're messing with the soil or you're planting something somewhere where it doesn't go, like on a hill, right? That's not going to go well for you. This is when the soil surface is directly exposed to rainfall, runoff, and wind. The erosion rate is faster than the formation of new soil. So you're losing soil faster than you're gaining new soil from organic matter. And obviously this reduces the amount of productive soil that you have. So you don't want that. You want good soil. Erosion. Basically, this is accelerated by the removal of vegetation. When we take the vegetation that should be there, the grass, the trees, when we take that out, it exposes the soil to erosion. So this can happen from overgrazing. This can happen from intensive, repetitive tilling, or just tilling in general. This definitely happens with deforestation, right? So again, we're back to the rainforest. You've got questionable soil. But what you do have is all this great organic matter of plants that are growing on the top. So it's growing on top of that layer. You take all that plant away, the soil is actually terrible. You get what little organic matter you have on top of there, it's getting eroded because you are planting a crop and then removing the crop and planting a crop and then removing the crop, and you're not able to ever restore that soil. So erosion, we don't want that. It's bad. You do not want to erode. This is essentially a loss of your organic matter, that really healthy layer on top, that layer on top of your soil. You want that to be as big as possible and as healthy as possible. Again, affected by the same factors as general erosion, caused by drainage, caused by too much tillage, increases the amount of oxygen in the soil, and it makes your microbes a lot happier, I guess. So they break down the organic matter faster, and then it actually disintegrates faster. Compaction. This is essentially you drive over a field over and over and over. You see this maybe on campus. I haven't seen a ton of it, but you can kind of see it coming out of AB. It's where there probably should have been a sidewalk, but they put the sidewalk somewhere else, and everybody just walks through that path anyway, and grass doesn't grow there. That's compaction. You're just pushing the soil down over and over and over. You get that when you put heavy equipment on wet soil, or you just are constantly driving over the field. And it's essentially the amount of the solid mass in a volume of soil. So it's dense. It's just increasing the density. Bulk density is the mass of dry solids versus the volume of the media. You don't want your soil to be so dense. You want it to be a little fluffy, like not super dense where roots can't grow through it. That means your pore space is really small, so you don't have space for water to be there. Root penetration, roots can't get through it. It limits the water and the nutrient uptake from roots, and it just creates a compacted area right by the soil surface that doesn't let roots go down very far and will increase the chances of your plant dying from not having enough water and wilting. Compaction is much easier to just prevent than try and correct. So using lighter equipment, you will notice that tires are wider to try and spread out some of that weight. To use a proper moisture level, so basically not driving on the field when it's even a little bit wet, no excess tillage or just no tillage at all. Leave green manure. Green manure is like alfalfa, any kind of crop that you're growing that actually just leaves manure, leaves residue there, not like animal manure, but green manure would be a plant that you purposely leave in the field so that it will decompose and release its nitrogen. It's called green manure. Any kind of crop residue left on the surface will decrease compaction and erosion. Okay, here's what it looks like when your soil is all compacted. You've seen this on campus or somewhere, right? Where everybody's walking on it and they're just pushing it down and now it won't grow anything. It's a dense, hard surface. It's usually cracked. It has very fine soil that hardens. It almost looks like concrete. There's no water infiltration, so it like puddles and ponds right there. There's no gas exchange. Seedlings can't emerge. It's not good. You don't want it. Here's kind of light compaction, moderate compaction, severe compaction in terms of water infiltration rates. Salinization is basically an increase of salt in the soil. It's a result of irrigation in semi-arid regions and saltwater coastal areas. It's essentially just irrigating too much with the salty water, and it accumulates in the soil. It creates like a salty part You'll see it on hillsides. Again, you'll see it in Missouri where it's cut away. You'll see that salinization. It's like a salt buildup that's there. Okay. Saltwater intrusion, not a huge deal in Missouri. I know that's shocking, but we don't have an ocean. We don't have a ton of salt water in terms of oceans. So it's usually coastal areas, and you will see the salty seawater move into wells and things, and the wells will become too salty, the water table will become too salty, and then you'll see the soils actually become too salty. A really great thing to do that everyone's encouraging, that I'm encouraging. I give talks on this. I do all kinds of things to encourage people to grow a cover crop. Basically, the more plants that can be actively growing on a field, the better. So after you harvest your corn, if you could plant something there, like an alfalfa crop, really cereal rye is what we recommend. It's cheap. And essentially, if you will leave it there so that the soil isn't just bare all winter. It has a crop that's holding it there, that's keeping, if you think the rain comes down, if it hits plants, it doesn't hit the soil so hard. It hits a plant, and that softens the raindrops, the hard raindrops, or the hard snow. The other thing it does is the roots will hold that soil in place. So the roots, remember, have a chemical reaction with the soil particles. So the live roots that are, they have the microbes, they have all these things happening. That keeps the soil in place. If you just take your corn crop off right now, everyone's harvesting corn right now, and you leave nothing on the field until May, you are really leaving your field unprotected in terms of erosion, because every heavy rainstorm, all the snow melt, all that stuff is just moving that soil around because you don't have a plant there to protect it. That's called a cover crop. Again, large quantities of organic matter repeatedly. So that's leaving all of your plant residue on the field so that it can decompose and create organic matter. That's why you want to do that. Here is a really great no-till field, right? See all of this cover right here? That's protecting the soil. It's keeping it where it's supposed to go. It's keeping weeds out. So no-tillage essentially is seeds dropped in the shallow plow trench here, just a little chisel plow. There's also something called a no-till drill that you can use that doesn't disrupt the soil. It prevents crop residue. It allows crop residue to stay and prevents it from being just taken out of the field and all those nutrients with it. It protects from erosion. It prevents soil erosion. It helps the structure of the soil stay intact. It improves organic matter. And it essentially just helps with overall soil health, which is the term that you hear right now is soil health and how your soil can be healthy. C to N ratio, we talked about this, and we talked about carbon to nitrogen. You want a low C to N if you want those nutrients from that plant to be available. So essentially, a low C to N is that plant will decompose quickly and those nutrients will be available. A high C to N will be the plant will decompose really slowly and it will take a while for it to release those nutrients. You actually want something in between. Again, material with a high C to N provides carbon food for soil organisms, especially fungi, and requires nitrogen for their own metabolism. That ties up the nitrogen in both the plant and the microbes. So you have to provide nitrogen to prevent deficiency from plants, even though there's nitrogen in the plants that already took it up. If you have something with a high C to N, it's not going to decompose very fast. And if it does decompose, a lot of the nitrogen is going to be held in those microorganisms, and it's going to take them a while to release it. Again, saline soils flush with fresh water to flush salts away is the way you would remediate that. Zodiac soils. This requires incorporation of calcium salts, usually gypsum. We put gypsum on fields. The calcium replaces the sodium in the CEC sites, and the sodium can then be flushed out. Reverse osmosis can also help, but it's expensive. This is only for high value crops, like high horticulture value crops, because then you have to dispose of the waste and it's rarely worth it. Erosion is most severe where torrential rain occurs. So East Africa, China, parts of Eastern Europe, Latin America, United States, Austria, and India. Not entire nations, but some nations are hilly. They have high rainfall areas, and some of them have semi-arid regions, and that means that they're really easily eroded.